What we're learning about is factoring today. You need to listen. You always need to listen, but you better listen for sure today. And I'm recording this class today instead of others, so. 3.1, we did a problem like this. 3 times 2x plus 3. What do we get as an answer? What did we do?
3 times 2x.
We multiplied through, right? We got an answer of what?
6x plus 9.
This is what we did in 3.1. In 3.2, we're going to do just the opposite. We're going to start with 6x plus 9, and I'm going to have you what's called factor that into 3 times 2x plus 3. So you see what we did yesterday? It's like today we're pulling them back what? Yesterday we multiplied the 3 in. Today we're going to pull the 3 back what?
Out.
That's what factoring is. Just as when you learned what 3 times 4 was 12, later on you learned that 12 divided by 3 is what? 4, right? So the first thing into doing this is and something you guys need to talk about, make sure you know what it is. What is GCF?
Good.
Common factor. When we start learning about factoring, you've got to learn how do you find the GCF. How do I find the GCF? Let's start with an example. We'll make our example 2x squared plus 6x. And I want you guys to tell me what the GCF is here. Okay? So first we're going to learn how to find the GCF. Then after we're done with that, we'll talk about how we factor out the GCF. But first, how do we find it? What I tell people is split it up into 2 GCFs basically. First, find the GCF of the numbers in each term. So that's what we're going to find first. What are our numbers here? Tell you what, stop writing. Everybody stop writing. I'm going to make you a break today because I want to write down steps and I want you to have them. After we're done with this, we're going to make copies. Okay? So every single eye, every single ear should be up here on the board. You can't do this, of course, every day. But today we're going to do this. Because this is something that people have problems with, and I think it's not that hard. I just think people get I think sometimes as a teacher, when we're writing down some of these rules like this, you guys get too caught in on writing it down as opposed to listening what we're actually saying. Okay, so again, what are our numbers here for this problem? We're finding the GCF here. The GCF of our numbers. What are our numbers? 2 and 6. Well, what is the GCF of those two? Greatest common factor means the numbers that will divide, the biggest number that will divide into both of them evenly. 2. The numbers that will divide into 2 evenly are 1 and 2, correct?
Yes.
Numbers that will divide into 6 are 1, 2, 3, and 6. What do they have in common? Largest one they have in common? 2. So the GCF of our numbers is 2. So we've done that step. Second, find the GCF of the variables in each term. Now, GCF of our variables. That's what we've got to find right now. Well, what are our variables? What are they? Please pay attention. Turn around here. What are our variables in this term? What are the variables in this one? X squared and what? Now, if you think about it, what does this mean? This means x times what? This means x. So, here's how you guys need to look at the variables. How many are at least in each? There's in this term, there's what? 2 x's. In this term, there's 1. What's the most in each of them? 1. So I can only pull out one of these x's, can I? So x is the GCF of my variables. It's simple. There's 2 here, 1 here. There's at least 1 in each one. So that's my GCF. So I combine those two to get my GCF. My third step is then combine my GCF is what? 2x. It's that simple. You worry about the numbers, then worry about the what? Variables. So, now how do I factor that out? What I do,
We can't see.
okay, what I do is I put my GCF was what? 2x. My original statement was what? 2x squared plus 6x, right? I pull my GCF out in front of the parentheses, and I leave a nice big set of parentheses, because I may have 2 or 3 things to do here, right? And what I say to myself is 2x times what equals that? 2 times what is 2? 2 times what is 2? 1. So you see how when I multiply through, I get that, don't I? X times what is x squared? I factored out one of those x's, leaving one of them inside. That's what's left, right? Then for the next term, I say 2x times what is what? 6x. Don't forget to put a sign in between these two. 2 times what is 6? What kind of 3? Positive 3. X times what is x? Well, x times 1 basically, right? So there were none left, no x's left here, so it's just a 3, isn't it? Because you pulled the only x out that was in that one, didn't you? Agreed? You're done. That's factoring out a GCF. That's not so terrible, is it? Okay. I'll send that up there. Now you guys can start writing. Let's do another example of this. They just ask you to factor. We'll say factor out the GCF. So what's the first thing I'm going to have to find? The GCF. And this I want to see on every one of your problems. Over to the side, I want you writing out what the GCF is equal to. Okay? Everybody understand that? And label. Not just writing a number to the side and me hoping you know what you mean. First of all, what am I going to deal with? See, now we don't have to, write out the steps like I did on that other one, right? We're just going to look at those steps. First thing I do, find the GCF of the what? Numbers in each term. What are my numbers in the term? 3, 9, and 24. What's the GCF? Well, if you need to, you could write them here. This I don't have to see, but if you're a person who needs to see this, then 24 is what? 1, 2, 3 times 8, 4 and 6, 8, and 12, and 24. Those are all the factors of 24, aren't they? Well, what's the biggest that all three of these sets of numbers have in common? Number 3, isn't it? So what's the greatest common factor of the numbers? So you write 3 in there. It's not nearly as complicated if you think of it in numbers, and then once you get the number, now you worry about the what? Variables. Now, guys, I'm telling you, if you can see, now I don't expect you to write this down every time, but if you can see this x to the 5th as this in your head, 1, 2, 3, 4, 5 x's, right? How many here? 1, 2, 3, 4, right? How many here? 1, 2, 3. Is it pretty easy to see what's the most they all have in common? How many are here? I mean, if I put a bunch of pennies in a pile and said, okay, there's 5 pennies here. John over here has 4 pennies. Nikki has 3 pennies. What's the most that all of them have? At least. They all at least have 3. So guess what the greatest common factor here? X to the? Isn't that pretty easy? No? But that's really, in my opinion, aren't the variables in essence kind of easier than the numbers? Because the numbers, you have to remember all these factors of these multiplication tables you remember. Agreed? The variables is just a matter of counting how many you have of each. Well, so now my next step to factor this is to write 3x to the 3rd out in front, leave a nice big set of parentheses, and write what's got to be left in here. Now, everybody don't write and watch here. 3 times what is 3?
1.
I don't care if you have a 1 in there. I'm fine with that. Okay? In the back of the book, there'll just be the variable there, won't there? That's okay. Now, here's the thing. If you can visualize this in your head, it's real easy to see what's left. I took out how many of these 5?
3.
3 of them, didn't I? How many are left?
2.
So x what? How easy is that? Okay, now here, 3 times what is a positive 9? And worry about these signs.
3.
What kind of 3? Positive 3. So write down positive or negative. That way you're separating them with the sign like you should. X to the third times what? Well, I took out how many of these 4?
3,
How many are left?
1,
So just write an X there. See how easy that is? Here, 3 times what is a, what kind of 24?
-8.
Negative 24. So it'd be a negative what?
8,
Now, I took out 3 of these what? 3. So how many are left? None, right? So that's the only thing left there, isn't it? You're done. But in the most part, can you kind of see this in your head without having to write it out every time? Do you see what I'm saying? That's how I think you should think about those. And it's not that difficult, is it? What's funny to me is it's we're getting ready to factor some simple trinomials. It's funny that sometimes people have such a hard time with factoring out the GCF because there's not a set rule like there is with some of the other stuff. Okay? Well, how about for this one? I do. Trying to see where my points from last. Okay, well, let's make it. Okay, let's do 3x to the 4th, y to the 2nd, minus 5x to the 5th, y to the 3rd, plus 10 x y to the 5th. Does that look like a messy, ugly problem? Yes, it does. But piece by piece, it's not so bad. The fact is, what's the first thing we gotta do? Factor out a what? G, C, F. Now, everybody up here, what's the first thing we find the GCF of?
each one.
I don't expect you to look at that, oh yeah, the GCF's x to the 3rd, y to the 4th. You know, that shouldn't pop into your head. I'm not saying that's what it is. But if you look at it piece by piece, you can answer the questions. What's the greatest common factor of 3, 5, and 10? What's the only 2 numbers that go into 3? 1 and 3. Just because there's numbers here doesn't mean the GCF is anything other than 1.
That's what I said.
The factors here are 1 and 5. Factors here are 1, 2, 5, and 10. What's the only one they have in common? The number 1. Now, if with the variables we find out that GCF is 1, then it's already factored. But let's look at the variables now. Now, should I look at x's and y's at the same time? No, make things easier on you. Try to figure out how many x's they have in common first, right? I have how many x's here?
4,
How many here?
5,
How many here? What's at least how many in each of them?
1.
Really, there's only 1, isn't it? So x. Wasn't so bad, was it? Like I said, the variables are easy. Well, how many y's do they have in common?
2.
There's how many here? How many here? How many here? At least, they have at least how many in each one?
2.
So now you've taken care of all the variables, haven't you? It's just a matter of now factoring them out. I'm not going to put the 1 there. Is that okay?
That's not okay.
The nice thing about having a 1 here, what's the number going to be right here? 1 times 3 is 3, right? It's not going to, any of these 3 numbers are going to change, are they? Okay, I factored out 1 of how many of these 4?
4.
One of the 4, right? So how many are left?
3.
So this would be x to the what?
3.
See how together they make 4 x's? Now, what needs to be here?
Minus
Minus what?
5.
I factored out how many x's? Oh, what did I forget about?
Y.
1.
I factored out 2 of the 2 y's. Are there any y's left?
No.
No, they're all gone. Okay. Well, I got lucky and left out the right one to leave out, didn't I? Factored out 1x to this next term. How many are left in here?
4.
I factored out one of them, so how many are left?
4.
So x to the, I factored out 2 y's. How many y's did that leave in here? How many? 1. Because I factored out 2 of the 3. What goes, now I'm done with that one. What's next? Plus 10. Factored out 1x. How many were in here? So how many does that leave? None. So I don't write anything. Factored out 2 y's. How many does that leave in here? Y to the what? Guess what? As ugly as that answer and that problems look, when it's all said and done, was that really that difficult? No, it wasn't. The next thing we're going to talk about is a very important thing, and we're going to talk about factoring x squared plus bx plus c. Okay? It's the easiest one. First, you write it down like this. You write 2 sets of parentheses. What do I put here, guys? You guys should remember this. What do I put here? X. What do I put here?
X.
Because x times x is x what? Then you find 2 special numbers. The 2 numbers who multiply to get C and add to get, you guys remember? B. You guys remember doing stuff like that? Here's an example. Does anybody remember what the first thing I'm going to do here is? Nope.
X's.
This is when they're in this form, x squared, x, and then just a number here. Okay? What's the first thing I do? Second thing I do is that. So the first thing I do is what? Draw this. What do I draw? They're all eyes up here. 2 sets of parentheses, correct? What do I put here? Only one person in the class knows. What do I put here?
X.
Then I find my special numbers, which I want you to find too. Now, here's what I do. I need numbers that multiply to get 20, because that's what C is, right? And add to get what? 9.
4 and 5.
Well, first of all, positive 1 times positive 20. What do those add to, though? 21. Will that work? Well, how about 2 and 10? What do those add to? 3 won't go into it. 4. How about 4 and 5? What do those add to? Do any of those work? Huh?
Yes.
Which one?
4 and 5.
So, what do I do here? I put those 2 numbers in there, and there. So I put plus what? 4 plus what? And you're done. That's not so bad, is it? However, I'm going to give you a tough one. Is this almost the same one we just did? Huh? Okay. My special numbers here were 4 and 5, right? And I want you to write your special numbers up there for me. Okay? Always put them in a box just like you did your GCF and then write them in here. Here, what are your special numbers going to be? Well, I need them to multiply to get 20 and add to get what? Negative 9. That's very important. I already did these two. I mean, not everything factors, right, guys? Do any of those work? They don't, do they? So does that mean this is non-factorable? No, it doesn't, because we always forget this. We always remember that a positive times a positive is a positive, right? Well, what would negative 1 times negative 20 be? Negative 1 times negative 20 would be a what? Would that be a positive 20? You guys agree? And those would add to a negative what? At the same time, a negative 2 times a negative 10 would be a what? Positive what? 20. And they would add to a negative what? 12. And then a negative 4 times a what? Negative 5 would give me a what? Positive 20 and would add to a what? So those are actually all the factors there. Does any one of those now work? This one right here, right? So the only difference here, x here, but instead of putting plus 4 and plus 5, actually what do we put? Miss Boyd, what do we put? Exactly. Minus 4 and minus 5. Correct? And you are done. I know we haven't taken a lot of long notes in here, but guess what? This is a little bit harder. I have one more problem to give you. X squared minus x minus 20. I want you guys to factor that. So first thing I'm going to do is draw what? 2 sets of parentheses, put an x here, put an x here. Here I found my special numbers to be negative 5, negative 4, right? Or negative 4 comma negative 5. I need to find 2 special numbers here. But here I need my numbers to multiply to get a what? A negative 20 and add to a what? What's the middle number? It's not written there. It's not negative x. Negative 1. What's the big difference here between this and the other ones I did? I need them to multiply to get a what kind of number? Negative. So these are all my factors, right? If you'll notice, negative 1 times a what? Positive 20 gives you a positive 19, does it not? Multiplied together, don't you get a negative 20 there? So when you got a negative number you're trying to multiply and get, one has to be negative, one has to be what? And you end up subtracting the numbers actually. Well, I could also do a positive 1 times a negative 20. That would still get that, wouldn't it? So that'd give me a negative 19, wouldn't it? See a pattern here? Let's try negative 2 and a positive 10. What do you get? Anybody? What do they add? They multiply to get negative 20. What do they add to? 8? What would I do then? I would just do a positive 2 and a negative what? What do they add to? Those don't work either. What's our last one? I could do negative 2, or I'm sorry, negative 4 and a positive 5. What would those add to? 1. Or I could do a what? A positive 4 and a what? What do those add to? Which one of these work? Huh? Our special numbers are 4 and what? Negative 5, because they multiply to get negative 20 and they add to get what? Negative 1. So what do I put in here? Plus 4 and what? And you're done. So we're going to do, you guys do have some homework, but you'll find you get done with this pretty easy. We have a little bit of time left, okay? Tomorrow we'll do a worksheet on this. And as you get to work, finish writing that down and get to work right now.